pretty interesting to me because, well, I'm a computer science and psychology double major. So just throughout my studies, I've noticed a few places where these two fields overlap, and I just wanted to share with you all. So just as a quick overview of this presentation, I'm just going to start by talking for a bit about what interdisciplinary studies are, and then go on to just like talk about how computer science and psychology just kind of overlap in general. And then I'll go into a lot of the subfields that basically borrow from both of these like disciplines. So cognitive science is a really big one. Human computer interaction, that's supposed to say, is another one. User experience derives from human computer interaction. We'll go on for a bit about social computing, which I found out about while researching this talk. We'll talk about how software engineering is influenced by psychology, and then finally we'll end on artificial intelligence. Okay, so interdisciplinary studies are this idea of like multiple disciplines overlapping in some way. Effectively, you can take almost any two disciplines and find some way to combine them somehow. Like with computer science, for instance, biology and computer science tend to overlap in the area of bioinformatics, where like people might be studying gene information to just understand the human body better and deal with things like illnesses. Cybersecurity is a field of overlap between like forensic science and criminal justice and computer science. And I know that's something that's very popular at the school, and I've seen a lot of people study a lot about that. Now, with psychology, we see similar situations where like you might have environmental psychology, which is the idea of combining sustainability practices and psychology. So like people might be trying to see how can we influence people to live more sustainably in their everyday lives? Or like how can we better combat climate change and like push out advocacy for this using psychology concepts. Then forensic psychology kind of hits on a similar note to cybersecurity, where we're combining like aspects of criminal justice to understand, well, like the criminal mind and how we can better stop crimes. So how do computer science and psychology overlap? Well, usually they overlap in terms of design. Design is kind of a field in itself, but psychology plays a lot into it. So basically, a lot of times it boils down to we want to make software for people and we want it to make it easy to use. No one wants to use a program that's unintuitive or like has a high learning curve to use. And if programs aren't designed in such a way, then well, people just usually aren't very engaged with them and might just move on to use a program that does it better. So there's an aspect of competition to it all. Also, in terms of like some of the theory that we see in both of these areas, there's some overlap as well. Cognitive science is a huge field, like combined from a lot of different areas of theory, and artificial intelligence kind of borrows from like we kind of use ideas of how like our own minds work and try to replicate them in computers to use computational abilities to do it better than we could. And also there's areas of subtle overlap between fields where like, well, maybe you're just designing software for a company that happens to focus on psychology. Like you might see a lot of apps out there like Headspace or meditation apps that aren't focusing on mental health or perhaps are designed as tools to help like clinicians in their daily lives. And well, these apps have to be designed with the field in mind. So cognitive science, this is a doozy of a field. So cognitive science was founded in the mid 1900s as a collaborative field between six different disciplines, arguably seven. So obviously there's psychology, there's philosophy, there's linguistics, anthropology, neuroscience, and then artificial intelligence / computer science, depending on who you ask. And effectively, altogether, this is the study of cognition, which is the study of how, like, people and, well, just in general, how we acquire knowledge and process it. What structures are there to, like, how we, like, communicate information, how we, like, might turn information into other information. So, like, using linguistics as an example, like, we communicate information through our speech, and other people might be able to interpret our speech differently depending on little nuances in our speech. Anthropology, well, there's a whole social aspect to, like, and cultural aspect to, like, how information is conveyed. But let's focus more on psychology and artificial intelligence. In psychology, we kind of have this idea of cognitive science as a white box model of the mind. Some people in psychology prefer a black box model of the mind, which I'll get to in a moment, but the white box model is basically we perceive stuff in the world and our mind does something. We're trying something to, like, process that information and turn it into different things. Like, well, I'm trying to think of an example. Like, I might see a dog on the street and I say, that's a dog. Clearly there's something going on in my mind to, like, register that I just saw something in front of me that perhaps is brown and furry and matches a set of features, and that is a dog. Now, there's similar processes for more complicated things, like when you're playing a video game, how might you, like, know how to do certain things in the game? And that's the whole idea of these processes. Now, these same processes, as I'll get into later, can be replicated in computers or in other areas. And, well, in computers, well, that's where we get into artificial intelligence, where we effectively want to simplify how our mind works and replicate it in a computer. Now, for comparison, there is also black box models of the mind in psychology, which that's more getting into behaviorism and the idea of reinforcement. So, like, for example, there's the idea of operant conditioning where, without using too much jargon, you might have a dog and you want to train it to, like, sit down when you tell it sit. So perhaps you'll encourage it to sit, and whenever it does it, you'll give it a treat. And over time, as you keep doing this, the dog will be more and more likely to sit down and in response to you saying, sit down. Now, and this also can be used in artificial intelligence, where there's the whole idea of reinforcement learning, which I'll get into later. But that's more of a black box model of the mind, where we just see the input and output. We don't know what the dog's thinking when we say sit down. We're saying sit down, which is the input. The dog does something, and that thing that it does is the output. Okay, so let's get into the idea of human-computer interaction. This is probably the main field that is directly a combination of computer science and psychology. There's actually a lot of master's programs out there that study this field in particular. Especially, I believe Carnegie Mellon University has, like, an entire institute dedicated to this field. But basically, it's a combination of computer science and cognitive science and psychology, and also design, and there's an emphasis on human factors engineering, which I'll get into in a moment. But human-computer interaction is the study of how we interact with machines. Like, I guess, like, we're interacting with machines to get a certain output from them. Like when I go on my computer and I'm trying to share a presentation, how do I go about interacting with it, for example? Like I might go on Chrome here, I'll design a presentation. Let's say I want to share it. Like what what's the thought process behind what I might do? I might perhaps there's a button. If I click present and let's say I press it, I'd expect that it should bring up the presentation. But what if I press the button and it didn't work? That's kind of where there's an issue that we wouldn't want happening. Also, there might be alternative ways that a programmer might put in, because maybe not everyone expects to look up here for a present button. Perhaps they think, okay, there's these different ways, these different drop-down menus that are standard across most programs. Maybe there's another way to present here. And it doesn't look like this actually. Oh, see, I was expecting to see it under slides, but it was actually under view. So that might be an aspect of information organization. Like interfaces are designed in such a way that they have to be built with how people might interact with them in mind. And essentially they have to be designed in such a way that they're in line with people's expectations and perhaps sometimes have multiple options. And also they have to make sure to be designed in such a way that doesn't lead to consequences for poorly using them. Like, I know I was taking a course on this subject online once, and they used the example of card readers at stores. Those are a piece of technology that people interact with to complete a transaction. Now, these have gone through several iterations through the years. Originally, you used to just have the swipe, but where you'd take a credit card and you'd swipe it down the side. These ran into a lot of issues because, well, if you if you pull out the card too soon, there might be an error where it's couldn't read the card right, or you might swipe too fast or too slow. These all cause friction between the user and the computer. So that's why more modern things have moved to using the chip, where you just push in a chip. There's no way. You can only push it in the card in one way, and it just sits there for a minute while the computer reads it. No need to worry about speed or pulling it out too soon, and then finally you can take it out when you're done. But there's another aspect to it. Some people forget their chips because they don't have, or their cards because they don't have to hold on to it the entire time like with a swipe. That's why they introduced this new way of, that's why they induced, sorry, I need to collect my speech. They introduced a form of feedback on these technologies where the chip readers will just beep at you until you will take your card out, because it would be undesirable for people to leave their card behind. And anyways, that's a side tangent, but in a way, this is all just kind of based on the idea of ergonomics, where we're trying to design technology around people and how they use it. So ergonomics kind of extends beyond the standard ways you might hear it, where it's just perhaps you have a mouse that fits to your hand, or you have an ergonomic chair that is designed to help keep your posture good. There's also aspects of just how things are laid out and how people might interact with technology that go into ergonomics. Okay, so next I'm going to cover user experience. User experience developers are a growing type of developer in the software engineering industry. this is basically a subfield of human-computer interaction, so the last thing I just covered. But basically, this is the idea that we want to think about like the interactions that people have with software and computers. This shows up in a lot of companies in different ways. At Jamf, for instance, there's an entire team of UX developers that work directly with software development teams. They work with multiple teams. At our companies, you might see UX developers working on every individual team specially. In other companies still, you might see that you might not have any you might not have any UX developers in particular, but you'll have front-end developers that have experience in user experience and kind of just design with that in mind. The big thing about UX developers is they don't really do much code usually. Ones that know more front-end development might do more of that, but usually they're more about the earlier stages of development. So drawing out wireframes, which is kind of what I have here on the side, where it's just like a rough mock-up of a website, perhaps just drawn by hand or on special programs that just kind of are designed to just like block out a website. What are the key features of the website? Like there needs to be boxes here, there needs to be a nav bar on top, and like sometimes there'll be multiple stages, like there might not be any coding to it, but like here's what the website looks like after you click this button, or here's like a little point on the website that'll try and draw user attention to what they should click next. Basically, the main point of user experience is to try and figure out where the friction comes in, where users encounter issues and how we can like mitigate those issues. If a user can't figure out how to do a certain thing with their software, like let's say you went on Snapchat, for instance, and for whatever reason, they made a really convoluted process for taking pictures. Since that's a central part to the app of Snapchat, like no one would probably want to use it if it was really hard to take a picture on there, which is probably why the app has like, last time I used it, I don't use it that much, but like I remember there's like multiple points throughout the app that you can take pictures. Like I think when you first open it up, there's a button you can just press to take a picture. Pain points, however, can appear in a lot of different places. Like in video games, you might, jumping ahead a bit, video games encounter a lot of pain points where you may have played games before that just have terrible control schemes or just unintuitive controls. And it's often shown in reviews that people don't really like it when their games aren't that intuitive to play. Like that's kind of a turnoff. And the same thing applies to other forms of software development, such as just like general creation of tools, websites, anything really. And that's why UX is kind of growing as a subfield within software development, and why a lot of companies are starting to hire a lot of like people with experience in this realm. All right, so next we have social computing. This was something I just kind of found out about while researching this, but it's pretty straightforward. It's just a field that focuses on social media platforms and like any form of like communication that takes place online, like usually in mass. This is kind of I believe it's technically a subfield of computer science, but there's aspects of psychology that come into it too. So basically, the idea behind this is replicating forms of communication that happen in real life via software and technology. This has been a huge thing during the pandemic in particular, as since we can't interact in real life, we're trying to find more and more ways to make the real life experience be online. So some of the more traditional examples of this we've seen is, well, obviously social media. So social media is just kind of this idea of just like, I don't need to go into it too much, but it's just like different ways of socializing online. Wikis are another type of socialization that I guess I never really thought about, but they're more of an informational way of, compared to social media, they're more about collaborating on information, building a project. So it's interesting where that might be more of like people gathering at a university to share information. That appears more in the form of a wiki online, whereas social media, that might be more like people hanging out with friends. And similarly, multiplayer games, well, those emulate a lot of different social contexts. If you're playing an MMO like World of Warcraft, that could emulate like very clearly a lot of aspects of real life, especially if you get into like aspects of role play or other parts of it. Whereas if you play, I guess, an online game of solitaire, like, well, I guess solitaire is single player. If you're playing a multiplayer poker game via an app on your phone, that's a different social context than World of Warcraft. Interestingly enough, sometimes the situations that we see in like online contexts like World of Warcraft can be studied psychologically or sociologically and applied to real life. I believe it was in the early 2000s, I believe, there was a particular event that happened in World of Warcraft by pure accident. Essentially, there was, how do I describe this? A debuff or there was an illness in the game that was supposed to be only affect high-level players in a specific area of the game. Like, this area was walled off from the rest of the game. While players were fighting a boss, they would get this illness where other players around it would spread to other players around them. When they left the area, the illness was supposed to just go away. However, there was a bug where I think it ended up somehow escaping the area through pets, and it ended up spreading through the common areas of the game. The bad thing about this was this illness was designed to like slowly take out the health of high-level players. However, low-level players, when they got affected with this illness, which they were never supposed to be, would be killed in a few seconds or in a short amount of time. So suddenly there was a plague going on throughout the game, and researchers decided to look at this and found that there was a lot of insights, a lot of similarities to real life like plague behaviors that could be studied in the game. And honestly, I'm curious to go back to that study and see if how many of those were accurate to behaviors of people in, well, the current pandemic. Because you have people that might go around like in a game like spreading an illness purposefully just because they don't see it as very consequential. Other people might be trying to help other people. Like in a game, you might have priests or healers that can cure the illness, or you have other people that are trying to help by like promoting like, don't go to this area. There's a lot of people sick here. But that's a side tangent. Again, there's going to be a few of those. And then finally, we have like online dating as another example of social computing, where that's obviously a lot different from real life. And there's been a lot of research into how to like improve that experience and how like different users of online dating apps have different experiences. So finally, let's get to artificial intelligence. This is obviously more of a pure computer science field, but as I alluded to earlier, there's a lot of aspects of artificial intelligence that come from just models of how we see the brain. Artificial intelligence has a lot of subdomains, and some of these might be more relevant to psychology and cognitive science than others. Deep learning is one that is particularly relevant, but robotics so much, I mean, you could probably argue robotics has connections to human-computer interaction where, like, if we have robots that are doing things for us, that's an interaction between a human and a computer, and that's where that field kind of plays in, but I digress. Natural language processing is an area of artificial intelligence where that fits more into linguistics, so I guess that's not so much a psychology one. But let's get into like an example of how psychological models are used in the field of artificial intelligence. So in cognitive science, there's this idea of connectionism, where it's kind of inspired by how neurons work in our brain, or how we think neurons work in our brain, where a neuron associated with a specific concept might be activated when we see something in front of us. And neurons are connected to other neurons, which are connected to other neurons. So when one neuron gets activated, the neurons it's connected to also get activated, but a little less so. And then the neurons connected to those neurons also get activated, but even less so. And the idea is, if in the end, after these activations occur, then our mind kind of just looks at, okay, what's the most activated? Like if we see brown four-legged animal in front of us, we might have those specific nodes in our brain activate. And together we know the collective of that as dog, but maybe we see something that's confusing. Like not quite dog-like, but still brown four-legged animal. Perhaps it's a bear instead. Oh, and well, we'd probably learn this as a child, but we're told, no, that bear is not a dog. Our brain would take that feedback and kind of learn like, okay, maybe a way to distinguish a bear from a dog. A bear is larger. So if something's really large, not a dog. But anyways, that same idea is kind of applied to computers. So I believe it was the 1960s or 70s, a mathematician decided to try and model a neuron with math, as one does. And on the right here, we have a rough depiction of what that is. This is a perceptron. A perceptron, without getting into too much of the math, takes a number of inputs and does some fancy math on those inputs, like a neuron kind of thinking, and gives a singular output. So like in this example, this perceptron might be kind of like that idea of you seeing a dog, and you're breaking it down into features. So one of the inputs might be brown fur, four legs, and then waggy tail, or man, I should know more about dogs. 2 eyes. And then the fancy math in there says, okay, yeah, this aligns with what I'm used to. So yeah, that's a dog. Or it would give like a 0 or 1 output, true or false. Is this a dog? That's what this perceptron is trying to do. And if the inputs align with what it's used to, yeah, it's a dog. If they're not, no, it's not a dog. And neural networks are built using a bunch of these perceptrons connected together. The exact math behind it is a little hard to explain, but basically, if we take a bunch of these perceptrons, artificial neurons, and put them together, theoretically they should work pretty similar to how our brains work. And, well, at the original point when these were created, computers weren't that good at processing complex math. So perceptrons kind of just got put off to the side. Brains are complicated, and it takes a lot of processing power to fully replicate a brain. But now computers are a little bit better. Maybe not quite on par with the brain, but in some regards, but like we've made strides that actually make this complex math actually approachable. And now we can actually build neural networks, and evidence shows that they're more effective. They're pretty effective ways of completing artificial intelligence tasks. Now, perceptrons get into more neuroscience rather than psychology. So, which, I mean, the two fields are connected, but let's get into something that's perhaps a bit more psychology related. There's also the idea of reinforcement learning, where, kind of getting back to an earlier example I had, where you might give a dog a treat to try and give a dog treats repeatedly in order to train it to sit. Why don't we do the same thing with a computer? Well, obviously computers don't like treats, but you can tell a computer if it did something right or wrong and tell it to try and go towards always getting something right. So I think this kind of gets into the idea of supervised machine learning, where basically we'll give a computer a bunch of data. We already know what the data is, so like we'll give it a bunch of pictures of dogs, but we won't tell it ahead of time that they're dog. We'll give it a bunch of pictures of dogs and also a bunch of pictures of cats. And we have the labels for all those things, but we won't tell the computer what those things are. So we'll just feed the computer that, let it figure it out, and just kind of let it be like, okay, have fun with these. And at first, have fun with these, tell us what each of these is. And at first, it's going to be like just complete guessing. Like, this is a cat. No, that's a dog, clearly, computer. But over time, after repeatedly correcting the computer, it'll figure out the minute differences between the cat images and the dog images and be able to more accurately tell when we give it an image of one or the other that it is one of those respective things. We're kind of reinforcing it for getting right answers, and I guess punishing it for getting wrong answers. So until it gets to an optimal state or a near optimal state. Usually these aren't perfect methods of training that we do with computers, but I digress. So I guess that's actually most of it. I hope that this presentation has informed you all about some of the way that there's been an overlap between computer science and psychology, and perhaps inspired you to think of like places where like other fields that the different fields that you might be interested in might overlap in various ways. Thank you. And if there's any questions, feel free to ask. Thank you, Sam. Well, if there's no questions, thank you all for coming.